Good evening everyone. Welcome to the Q&A session 39 from the playlist of NEET Physics Part 1. The topic for this session is the rate of the kinetic energy, and this is the topic from the chapter of work, power and energy. So today I have taken one question which was asked in the CBSE All India Pre-Medical Test in the year 2010, and the question is: an engine pumps the water through a hose. The water is leaving the hose with a velocity small v. If small m is the mass per unit length of the water jet, then what is the rate of the kinetic energy imparted to the water jet? So we know that the kinetic energy, say K, is equal to 1 by 2 mv square, where m is the mass of an object and v is the velocity of that object. So the rate of the kinetic energy will be equal to dk upon dt, or we can simply write this as so the rate of the kinetic energy will be equal to dk upon dt, and since k is equal to 1 by 2 mv square, so this can be further written as d upon dt of 1 by 2 mv square. Now in this question, the water is leaving the hose with a velocity v, so here v is constant, Now here m is the mass of this water jet. Now we are given that the small m is the mass per unit length of the water jet. So the mass of the water jet say it is equal to m, so this is equal to m into L, where L is the length of the water jet. So if the length of the water jet is equal to L, then the mass of the water jet will be equal to m into L, where m is the mass per unit length of the water jet, which is given in this question. So the rate of the kinetic energy, that is dk upon dt, this can be written as d upon dt 1 by 2. Now m is the mass in this equation, and so m will be substituted by this m into L and into v square. So the rate of the kinetic energy this is equal to dk upon dt, and this can be further written as, now here 1 by 2 m and v, they are constant. M is the mass per unit length, so this is a constant. V is the velocity of the water which is leaving the hose, and so 1 by 2 m and v square is constant, so that can be taken out. So this equation can be further written as 1 by 2 m v square dl upon dt. So finally, the rate of the kinetic energy which is imparted to this water jet will be equal to 1 by 2 mv square. Now dl upon dt is the velocity of the water, so I will be substituting dl upon dt by v. So this is equal to 1 upon 2 m v cube. So the rate of the kinetic energy which is imparted to this water jet is equal to 1 by 2 mv³. So here the correct option is C. So here the most important thing which you all have to remember is that the rate of the kinetic energy is equal to dk upon dt, and this can be written as d upon dt 1 by 2 mv square. So by using this equation, I was able to find the rate of the kinetic energy which was imparted to this water jet. So thank you very much for joining this session, and in the next session I will be taking up a different type of a question from the same chapter, that is work, power and energy. So till then, have a nice day. Bye.